Can you describe a couple specific examples? Think of a manufacturing company. You have some telemetry data from a particular device. Name that device, talk about the situation, the piece of data, just very, very brief example. And then the command idea and this event-driven data. Talk about a couple examples to compare and contrast to really help everybody listening to this podcast get a good grip on it. And then, Matt, throw it over to you after that to talk about some of the pros and cons, what your thoughts are. So, Geoff, let's make it real. Remove Dave kicking me out of the podcast and your kids ignoring you.
Let's get to I was going to use the example of the meeting has started now. You better join because Dave's joined.
That's good. That's better.
Yeah. So, quite a common example is the recipe download example. So I have a production line that may be making widgets, and it might have different widgets coming down the line one after the other to a workstation. And the widget arrives at the workstation. That's an event. Widget arrived. But now there's a command that needs to be fired by something that says, okay, I need to now grab the recipe for that particular widget and send it to a machine so that that machine now needs to do something for that process. So we have an event which is, this thing has happened, the widget has arrived at the work cell, and now there's a response to that event, which is a command to download a recipe into the control system, perhaps, as an example. And typically, an MES system would be issuing that command, maybe to another microservice or to another piece of software to say, please download that recipe. And where you can get a whole bunch of different failure scenarios is what happens if I receive that command to download the recipe and I can't for some reason. What happens to the command? Do I retry? Do I put that into a failure queue somewhere and request help from an operator? There's a whole bunch of scenarios there. And as we get more and more involved in cloud native distributed systems, this scenario and this challenge becomes exponentially more difficult. So imagine that I haven't got one application that can download a recipe for me. Imagine I've got a cluster of 3, all the same, all have the capability of downloading the recipe, and I can send my command to any one of the 3. So maybe Matt and Dave and Kevin all have the ability to download this recipe, and I can send the command to any of them. So I send it to Kevin. Kevin tries to download the recipe, but runs into an issue. So you've received the command, right? I've told you've accepted the command, you've tried to do it. But what happens if you fail? I need to know, as the person who issued the command, that you've not been able to execute that command. And now I need to decide whether I need to reissue that to Dave to give him a try, or whether I need to abort and try something else. So there's some very complex handshaking that needs to go on, not just at the message level, but at the application level, with acknowledging the execution of a command versus the receipt of a message.
So then how is it that MQTT falls down on this job? Or PubSub, etc.?
Yeah, MQTT does not have the ability to manually acknowledge a message. So a message is automatically acknowledged when it's received by the client in almost all the client libraries, MQTT client libraries. And very, very few of them actually allow you to manually acknowledge the message. So as the piece of software that's executing a command, in most other transport protocols or messaging protocols like RabbitMQ or Kafka even, if I receive a message, I can automatically acknowledge the message, which you can do for broadcasting and streaming and so on. But for transactions, I can manually acknowledge a message after I've processed it. So that allows the broker to retain the message, know that you've received it, know that you're working on it, but I'll keep it until you tell me that you've actually processed it, and then I can remove it off the queue. And if that times out, or you come back and say, actually, no, I negative acknowledge that message, I, as the broker, can then pass it off to Dave to have a go, and then Matt to have a go. That capability is missing in MQTT.
Yeah, so this idea of the client-server relationship is tightly coupled to one another. That's where commanding is very strong. And you can see this in OPC UA, for example, where they have the concept of a method. And a server can expose its methods, can expose what parameters it needs for those methods. And then when a client calls a method, the server will reply back with some response code. Either the command was successful or it had any number of failures with trying to execute that method. So with MQTT, however, you've introduced this idea of a middleman, of the broker. And so the client is connecting to the broker and it's sending its command. But the whole idea of MQTT is I give it to the broker and then I don't care after that. The broker's job is to get it to where it should go. But me as the publisher, the idea of MQTT is that it's offloaded this idea of me as a publisher caring however many people are out there to receive my data. So for publishing telemetry, it's almost like a one-to-many relationship typically, where you have one publisher, one source of data, it sends it out with one packet, and then the broker can fan it out to as many clients as needed. So it's a very one-to-many relationship. But commanding is the opposite, where you typically have it's one-to-many in the opposite direction, or it's almost one-to-one, where you have the one source of the command that says, I want this to happen. It's going to send it to the broker, but it wants to also know, did the broker then send it to the application? And then did the application process it correctly? So then it needs to receive a message back through an additional 2 hops. So if we walk through the process, I want to send a command, I send it to the broker. MQTT would acknowledge that and said, oh, I received your message. Even if you do QoS level 2, which is a handshake back and forth to say that I did in fact receive your message and I'm going to only process it one time. So MQTT can tell you that, but that only tells you one step of the process. It only tells you that the command got from you as the source of the command to the broker, and that's all that you know. You don't know what happens on the other end. You don't know if anyone is even listening to receive the command, for example. So you could be sending a command to the broker and no one be connected, and it just goes into the bit bucket because no one is actually there to receive the command. And you, as the person giving the command, wouldn't even know that no one's listening. You think the process is going swimmingly, but in fact, everyone's disconnected and off doing its own thing. So the idea that this is where it's at the application level, really, if MQTT, or you modify MQTT to help in this regard, because MQTT only has the concept of telemetry. It doesn't have the concept of a command response within its architecture. So this idea that you're going to publish a special type of packet, and the broker knows, oh, I'm going to send this ARN, and then to the subscriber, I'm going to send it ARN, and I'm expecting for acknowledgement from the subscriber, and then I'm going to forward that acknowledgement back to whoever produced it. And so that is a totally new concept of MQTT, and there's really no way of standardizing it. Sparkplug it itself hasn't standardized it, so that could be a potential area for Sparkplug to help solve it, of this idea of I got a device, I want to send a command to it, and standardize how should that be packaged, and then what is the standard responses back to it.
So I'm going to summarize a lot of what we've talked about to help people catch up. Guys, confirm or deny whether I've done it right, and then I want to take some of these ideas further because this is getting really interesting. Some ideas that I haven't really even thought about too much. So MQTT, built in response to a lot of edge device, slow serial systems, Phillips 66, very popular today, lightweight, edge-driven, one-direction data to enable security, 80 to 90% less bandwidth eaten up by the packets, much more efficient structure, flat MQTT. Then comes Sparkplug-B to say, hey, let's add some more structure to it and add a couple other ideas. And that's where we all have been using Sparkplug-B a lot, like it a lot, along with MQTT, again, for device or, as Geoff calls it, it's a good word, telemetry data. Then we look at all the other data systems in a manufacturer that we want to work with. We'd like to get some really good contextual data from the ERP system. We'd like to get some results or planned downtime from the CMMS. We'd like to be able to send data to the CMMS. We'd like to integrate with other applications. We'd like to get into that very straightforward situation that Geoff talked about, recipe management. There's an event, product arrives at a station, let's download the recipe. But the weakness, it sounds like, because we are talking about MQTT, data brokers, one-to-many relationships, send the data off, it then goes to this middleman, the data broker, and then I have no idea what happens to it. As the most we can do, that I think, Matt, you had clarified, the most we can do is set QoS to 2, and then we can at least get a response back to the sender that the middleman received it. But after that, it's, as you say, goes off into the bit bucket.
Yeah, if you think about the movies when there's a drop where, I'm a spy and I need to get the information to my handler, I'm now going to take the message, I put it under the rock. I know I've put it under the rock. I have no idea whatever happens to it after that. Did somebody else get it? Did it get back? There's not the acknowledgement type of thing. So that's from a very basic level what's happening is I know the message got to the rock, but I have no idea what happened afterward.
Okay, so then bringing in the unified namespace, because a lot of this conversation is really around the unified namespace. So we have the telemetry data into the unified namespace, enterprise site area line cell. So think of, I live in Pittsburgh, so let's say we have a Coca-Cola plant in Pittsburgh. So Coca-Cola Pittsburgh, bottling line 2, bottle cell with Allen Bradley or Siemens PLC, and then you can see the data under that particular node in the tree leaf structure. But we want to start to get other contextual data into the system at other levels. How do we do that? And that's really what we're talking about. We can use client-server discrete connections with APIs and databases and use ETL tools, batch processes, but it's not real time, which is really what we want. So let's look for something better. Again, the knowledge graph or GraphQL as an API, so to speak, works well because it can not only allow querying data, but also subscribe to data as well. And then we started to get into this idea of being able to drop the message off under the rock, but we have no idea whether it gets to its destination. How does that relate? Or let's bring it back to the unified namespace. How is this important, Dave, around the unified namespace? The fact that we can't get that response back. Why do we care?
Yeah, so I think within the context of a unified namespace, that overall design methodology is not bad. We're structuring that data following that the master data model type of thing. It's really, for me, it's somewhat of the limitations of using an MQTT broker as that single UNS. And so really there's the two issues. One we just talked about is I send a message, it goes, and I know that it got it, but I have no idea what happened after that. And the other part is that since it's supposed to be that single source of truth, which is where we get into the whole being able to query what's happening there. So, where you run into issues there is that if I have, say, a time series database, or process historian is sometimes what it's known as, and I can pull some trend information back, And then also connected up to my unified namespace is some kind of data lake that part of it includes some of that time series information. If I ask both of those systems the same thing, I should get the same response. But because they're housed in two different areas, I might get something different. I don't have the ability to go to my what's known as that single source of truth to get that information back. So those are really, I think, some of the two fundamental issues we see within at least the broker within the unified namespace. Geoff, Matthew, is that kind of where you're coming from on that too?
Yeah, from my point of view, the unified namespace has two real purposes, and one is this single source of truth purpose, which is if I want to know something, where do I go to find out? That's one. And the other is as this sort of messaging broker for the flow of information, so we're not building point-to-point interfaces between all the various different applications in our environment, right? So we channel the messaging through the unified namespace so that we build single interfaces. This is where the unified namespace, if we only consider MQTT, has some real challenges as a not just it's fine for a where do I go and ask for the current state of something, but if I'm trying to provide a reliable transaction between two applications and I'm doing that over MQTT through a unified namespace, there's a whole bunch of scenarios where that has some challenges.
So we're saying that unified namespace as a concept for providing structure, plant model, etc. It's a good idea. A lot of what we are talking about is the tools, how to execute it. Telemetry, we're set, we're golden. Not telemetry, the event-driven data, transactions, we've got a few things to figure out. So Geoff, you were saying purpose of unified namespace is it's a place where you go to know where to find the data. You know exactly where it's at within the whole tree view structure. And the other one, are you saying that it's essentially not being able to query the data or something different?
It's transactions between applications. So if I have my ERP system release a production order and I need to have that production order processed into my MES application, there's two parts to that, as we kind of said before. There's firstly is receiving the message from the MQTT broker that a new order has been released. And the second part is processing it into my application, which means normally transforming the structure of the message into something that my application can understand, and then actually processing it in and making sure that all of the data lines up and that my application knows about the product that this order is for, and there's a whole bunch of areas where that might fail. And so handling all of those failure scenarios effectively and making sure that all of the applications as a whole system can work together becomes more complicated than just the putting the message under the rock scenario, publishing the message out there and hoping that somebody gets it and knows what they do with it isn't really a reliable enterprise system.
Solutions, ideas, guys, for that specific situation with this idea of getting transactions data between the systems? We've talked about a few things, but any additional thoughts? I mean, this sounds like a big drawback of the tools that we're looking at right now, MQTT specifically.
Well, the MQTT itself. Oh, go ahead, Geoff.
Yeah, I can talk for what we do at Libre. The problem's not new, right? Enterprise IT groups have been solving transactions across applications for a long time, and they've been doing it without REST APIs for a long time now. And so talk to anybody that's had some experience with Kafka or RabbitMQ, and they'll tell you how these things are solved. The concepts are actually remarkably similar to how an MQTT broker works. You still have topics, you still have messages flowing into topics, you still have subscriptions. All of these unified namespace concepts are exactly the same. You just have a few more tools to be able to handle guaranteeing transactional messages and handling failure scenarios than you do with the MQTT protocol. So, if you take the unified namespace as the concept of the ontology or the data model and how you structure your information and where you store it in the structure, but then you use the right technology to solve the right problems, then you can easily solve all of the problems that we've talked about here today.
Yeah. So another way we've approached this is that are there things within the MQTT and/or Sparkplug-B specifications that can handle some of these things? The idea of, can I issue a query command into my MQTT broker that is now going to provide a response? So that query command provides that, think of in terms of like a SQL statement of, select this where, an order type commands, but issue that to a particular space. So that's one area of taking a look at it. Another thing, and Matthew was talking about it, is the ability to, I sent the message, I know the broker got it, but I also need confirmation that the client or the receiver that I need also needs to get that response. So build that back in. So I'm using my SPY handler analogy. It's that not only do I drop the message underneath the rock, I also get notification that I can go back to that rock later on, pick it up, and see that there's some kind of token that says, yes, I got your message, type of thing. So there's a mechanism for those types of things occurring. And I think one other issue we talk a little bit about, and Matthew was talking about, is the idea of the wildcards. When Sparkplug packages all that information up, you get the entire enchilada, the entire namespace. Boy, it would sure be great if I could only get the information for the very specific packet, that telemetry data that I need. I don't need the whole thing. I only need one piece, and right now that doesn't exist. So, one way is Geoff was talking about, utilize other tools for doing it. I'm a big believer in using the right tool for the problem you're trying to solve. Another way is, that's something that we're talking a little bit about, is, are there things that can happen within MQTT that helps enhance some of this information, specifically for manufacturing?
So solutions to this challenge are using other tools, right tool for the right job, Kafka, RabbitMQ, RabbitMQ. These tools have been, and others have been solving these challenges for a while. Other alternatives are to look at MQTT and modify it. Is that what you guys are talking about?
Yeah, MQTT and Sparkplug as well. I know that I'm making several suggestions to the Sparkplug working group on how can we extend the existing definition of Sparkplug to make it more compatible or more palatable for IT systems. So, for example, what David was saying earlier, Sparkplug wants to package everything together. So if you have a PLC that's publishing its data, it's going to take all of its metrics that it has available, put them into a single packet, and then publish that to the broker. And that works well because the typical use case is that you have a single SCADA system or HMI, and the assumption is that SCADA HMI is going to receive everything. So it cares to know about every single metric that exists, and so it makes sense to optimize to reduce the bandwidth to package everything together as tightly as you can. But in the IT world, or when you're going up your enterprise, it becomes more and more apparent that you don't have one HMI or one SCADA, but you have many, many, many applications that don't care about everything. They care about very specific things. And so there you almost have to translate from the Sparkplug way of doing things, where it packages everything together in a binary format, to where you flip it over to going up in the enterprise of a way that's more digestible in small chunks. So can I translate from the binary way that Sparkplug has to a JSON way? And can I split it from the blob of all the metrics together into a topic tree structure, to where I can subscribe to just that one temperature value? So for example, if I have an application up in the enterprise where I'm trying to read all the power levels of all the equipment across the entire enterprise, and all I care about is power usage because I'm trying to monitor my energy consumption for the purposes of being a sustainable company. I have that one microservice running up in the enterprise, and it wants to subscribe to wildcard subscription, any plant, any line, any cell, your power usage metric. I can't do that in Sparkplug today. I have to manually make those connections in that topics space. But if I could have a way to translate that and break it apart into a way that makes sense, to where I can drill down automatically and find just those pieces of data and then get those only. That would greatly improve the capability of Sparkplug being able to be used at higher levels in the enterprise.
So telemetry, we care about lots of things. IT, we might care about one thing. MQTT supports the caring about many things. Summary, very high level. And so if IT, somebody wants to subscribe to a specific temperature of a specific device, maybe they're in facilities and they're not looking at everything, all of the data across all plants, but specific data across all of the plants, then use wildcards within that tree structure to be able to find just that one value across the whole organization. That one value, yeah, because the one value across many devices in a plant as well as across the whole organization.
That's
Is
right.
that fair?
And yeah, that transformational function can also be to where we actually are modeling our business to have a separate area within our namespace that's going to house all that power usage information, just to use an example. So that when it's transforming it from a Sparkplug binary, everything compacted together, and expanding it out into its different parts, it can also copy that same information over to this other part of the UNS. So that if you had this group or this function within the business that says, I really care about all the power usages, they only have one place to go find it. So that's another way to solve the problem, is that you start to collect all these little pieces of data and you shove them into one part of the UNS or the namespace to make it easier to find. And you can do that with any number of pieces of data where you're just either copying it over, replicating it to move it to make it more organized, or you're actually doing some kind of transformation on it and then moving it to another place so it becomes less raw data and more informational. So that's all. This whole other level of that we really haven't talked about is taking telemetry data and converting it into information. What's commonly becoming referred to as data ops. So that's a whole other layer of the UNS architectures, being able to transform data and shove this data that's coming from disparate systems into a way that's organized within other people of the business. They're able to understand what this data is and why they care about it.
Yeah, it's a big challenge.
Are you saying that?
One of it's
yeah,
a big
keep
challenge,
going,
and it's one of the areas where it's very possible to get into that multiple unit namespace world where you've got many single sources of the truth, because you're having to package up your MQTT namespace into, okay, if you're interested in power consumption, go here and you'll find information about this sensor. But if you're interested in all the sensors on this machine, including power consumption, go over here and you'll also find that information. So not that that's necessarily a problem, but it can become a problem if you have multiple namespaces. And so that's a great example of where GraphQL solves that problem by allowing you to query the context of the information, which you can't do in MQTT. So if you have all of that, all of your unified namespace exposed in GraphQL, you can very easily query for, give me all of the power consumption information without having to duplicate it across different areas of your namespace. Or you can query for, give me all of the sensors on this machine, including power consumption. Or, give me, something else entirely. It's queryable. And you can subscribe to those queries, which means I can get the information, but I can also get a stream of that information coming back to me. So this is where, stepping outside of MQTT can really, open up the throttle of the power of what you can do.
So again, to solve some of these challenges we're talking about, to really enable UNS to live up to its ideals, to its name, we have to look at ways to either work with MQTT, potentially modify how MQTT works, and or to look at other tools. And one of the tools brought up here in this conversation is GraphQL with the knowledge graph, et cetera. To that specific idea, I want to think about time here and keep the conversation moving. But just very briefly, we've just cracked the top of the can of the worms here for GraphQL. Can we just open up that lid a little bit more to really see what's inside? Briefly, Geoff, what are knowledge graphs? What is GraphQL, an API to the knowledge graphs? And then how is it actually working within the unified namespace? How would it work at a high level?
Yeah, so the easy way to think of it, I'm going to assume most people listening to this podcast are familiar with the unified namespace concept as it's described, right? Which is we have, a structure, a hierarchical structure normally of our topic names, where we can find somewhere to put all of our information in this tree of topic names. The challenge, as Matt rightly described, is what if the information I'm getting at is not on one branch of my tree, my topic tree here? So how do I get to all of the power meters if my power meter data is spread across this namespace tree? GraphQL is a query language. It's actually poorly named, in my opinion, because it doesn't actually have anything to do with graph as such. It's just a query language. So imagine being able to write an SQL query across the information in your MQTT topics, where you can join and you can link and you can query off to metadata about that topic. And so I can very easily say, okay, I'm interested in all of the information that's about power meters, give me that. Or I can say, I'm interested in all of the information that's related to this particular machine, give me that. And I can subscribe to that query rather than just being able to subscribe to a wildcard subscription in a topic name or a topic name structure. So the big challenge with MQTT topic structures when you're designing your unified namespace structure is designing it to be able to suit the types of wildcard queries that you're going to want to write on it. The problem is you don't really know what you're going to want to do with it in the future. And each different use case kind of requires a different structure in order to make it really usable. So that's where you end up with these multiple unified namespaces to suit different user groups or applications. So GraphQL really allows you to solve that problem.
So GraphQL, I look at QL, query language. I think about structured query language used for relational databases. I'm very familiar with that. You can query, do all kinds of creative and crazy things to query many tables, many fields in a table, many tables within a database, and many databases with across a whole network of databases if and as needed, though that's kind of inefficient, but that's a whole nother question. But applying this idea of a query language, are you saying that there is effectively an SQL-like query language that can be used for knowledge graph databases, and you're not storing the data in knowledge graph database, but you're using that GraphQL idea to then query something else, which is the unified namespace?
You could query your MQTT topics with a query language, yes.
But then where does the data live? If the data doesn't live in the unified namespace, literally because the unified namespace is an architecture, it's an idea, it's a model, then where does the data live?
Yeah, so your live streams of data are coming into the MQTT broker, right? So if what you're interested in is the current state of stuff, then your MQTT broker is as good as anything else as the source of that. If what you're interested in is the history of that information, or the what happened to this value over the last 2 months, then you're probably going to want to get that from a database of some sort. GraphQL allows you to join those two things together, and so you can query for the current state directly off the MQTT topics, or the history from whether that's a historian or it's an SQL Server database or whatever else it is.
So for the history, data needs to be stored, no doubt, can be in a knowledge graph database. But what you're saying is that we're applying the concept of using GraphQL to query directly to the unified namespace in the data broker. And because you had said earlier, connecting an idea, GraphQL can do subscriptions. So essentially you are writing, instead of using wildcards within the namespace structure that Matt's talked about, we're using a GraphQL query to watch, effectively to watch the namespace in the data broker with its own structure, wildcards or not, however you write that out. And then because it can do subscriptions,
and all of that.
Bada bing.
Yeah.
Right.
Yeah, the MQTT is very limited on, and Geoff was right to point this out, is that if you're trying to architect your topic namespace about how am I going to organize all my data and what topics they use to make it easy for consuming applications to know what topics to subscribe to then get the data that they want. That is an impossible job to create a topic structure that's going to satisfy all the use cases. Because first off, you're not going to know all the use cases that are there today. Yeah. And then all the future ones you'll never know about. So it's impossible to know that. And so you might as well give up on that effort. And so what Geoff's talking about is this, you create this abstraction layer on top of that. That's going to abstract away the MQTT broker. It's going to abstract away the database. It's going to abstract away all the other sources of data. And almost like an analogy of a restaurant is that you as a customer come in, you provide your order to the waiter then goes back to the kitchen. You don't know what's happening in the kitchen. It could be chaos. It could be they go next door to the store to get the food that they ran out of, but the waiter comes back with what you requested. And so an architecture like that is what's going to enable it to be scalable, because again, the technologies that are needed, there's no one solution to this. You're going to have to put together and piece together a tech stack of sorts to be able to supply all these different use cases. And so that you want to hide from the consuming applications, because that's very complicated. There's too many interfaces to know how to interface to each of them. So if you can provide that single API or that single, again, and that's what UNS is trying to be, is if you need anything, any data in the business, you come to me and ask, and I will find a way to get it to you. And then on top of that, it's ask me in this way, and then I understand what you're trying to ask for, and then I will know how to go do it for you. So the UNS is both a single location that everyone can go to, and it's also that agreed upon organization of all the data.
Well said. Well said. You're starting to summarize like I was just starting to think about summarizing to start to wrap up. One thing I wanted to throw out just for fun is I've heard out there in the ether that there is a Parris method and a Schultz method for the unified name. So what's up with this, guys? Come on, just briefly tell me what's up with this. Copywriting?
Yeah, no. So these were, I talked earlier about some of the challenges with Sparkplug and the ability to publish to the same group and node. And within the Sparkplug specification, those have to be unique. So if I want to bring in and structure that ISA 95 enterprise site area line cell, I really can't have a plant broker where I'm now publishing from a particular PLC directly into that, because I'm going to run out of that topic namespace because I want to publish enterprise site area line cell. Well, because if I use the plant and the area as my group and node, I can only have one item doing it. So the way that I go about solving that is that you set up multiple namespaces with multiple brokers, and I publish to that common broker, because the group node idea concept is that it's a logical grouping of devices. So if I'm in my packaging area, I'm going to have line 1, line 2, line 3. That's a logical grouping. So I would have packaging line 1, so to speak, as for an example. And then I'm going to have other brokers or other applications that are now consuming from that, and is part of its overall namespace as well. So I can roll those up into now have that site, and then have those area brokers as my group node ID type of thing. So that's the way I approach it, is that I can have these semantic models utilizing the enterprise site area line cell as part of those group node device IDs per the specification. So that's the so-called Schultz method.
And the Parris method?
Yeah, so this is all stemming from what is appearing to be a limitation of Sparkplug, of when you're trying to integrate Sparkplug into the entire enterprise. How do you name the group ID? Because that's really the only means that you have to segment uniquely different pieces of equipment. So do you have a globally unique name, meaning across your entire business, this group ID is never going to be used anywhere else? And or is it going to be a relatively unique name? So that means within a given plant, it'll be unique, or within a given work cell, it'll be unique. Because as you start aggregating the data up, if you have it unique to just a work cell, you're going to have conflicts as you start to try to merge and aggregate this data and federate it up. Because the work cell of plant A is going to have the same name as the work cell in plant B, and then how do you merge those two together? So the alternative method, and so David talked about how you can aggregate that up in a way where you're actually transforming the data as you move up the different levels to keep them from interfering with one another. But the other way to do it is that you create a group ID that's universally unique within your enterprise. And so a simple way to do that is just have a concatenation of your enterprise dash plant dash line dash work cell dash work element. And you know that no one else is going to have that group ID, and then your PLC or your device can have a unique node ID to publish into that. And so, but that becomes then complicated, because if you have this concatenation of enterprise, plant, area, cell, all smattered together, but then you have a consuming application that says, I just want to subscribe to all the things that are within a plant. Well, now you have to parse through all the different group IDs to sort out, well, which one is which plant. You can't leverage the native capability of MQTT where it's the different levels, and you can say, I want to subscribe to this level, and then everything underneath it. So that's, again, where Sparkplug could be improved, where you break apart the group ID. If you have, like, let's say, a standardized delimiter that says, if you use this delimiter in Sparkplug B and you convert it to, let's call it a Sparkplug C, I can now convert it to an MQTT topic structure. And then now I can insert, you would have at the top level of the topic, you'd have your enterprise, and then underneath that, you'd have all your plants, and then underneath that, you'd have all your lines. And so you could use the group ID as just with the delimiter separating out those different topic tree structures as a hierarchy, so that you can then kind of flip back and forth, translating from one namespace to the other.
You're muted, Kevin.
So there's got to be somebody in every call. It was me. So looking at the time, we've got to start wrapping it up. A lot of heavy stuff. Thank you, Matt. Mm-hmm. Thank you, Dave, for your unique methods. We have talked about a whole lot of ideas starting from the ground up of what is MQTT and Sparkplug B, what's the unified namespace, and challenges for each of these. We've maybe opened up and talked about openly the questions, have thrown around a few suggestions about possible ways to solve, but it's not done yet. The solution is not staring us in the face, the one single solution. What I would love to see happen, and maybe it can happen, is that we can get together again and continue the conversation with a couple more members on the panel here. But with that said, let's go one more last round for a minute each of you to give some final thoughts, either to summarize or open up yet another question. Feel free. That we can continue the conversation later. Geoff, why don't you go first?
I'll spend a minute describing the Nunan method, if you like. So,
now I have to hurry.
It's got to be one. Yeah, we can't have a Schultz method and a Parris method and get left out. So my method is leave Sparkplug B as a data source, not as part of your unified namespace. So yeah, connect to your PLC tags or your sensors and devices with Sparkplug B, you get great discoverability. Then transform that information from Sparkplug B and put it into your namespace. Ideally, put a GraphQL API over the top of that so that you can access it easily out of that system. Store it in a graph native database, even if you like, and even put a time series database plugged into the side of that with a whole enterprise model attached to it. That's the Nunan method. You can read about it on LibreMFG.com.
So it already exists. Nice.
Yeah.
Great summary. Good. Thank you, Geoff. Matthew, Mr. Parris.
Yeah, I would say today, a lot of, if anyone is frustrated with this and trying to solve solutions, it's because that this is also new, and there's not really any reference architectures that exist or readily available solutions that are just pervasive through the market. If you think about 40 years ago, the protocol wars that were happening at the low levels of networking, you had ThickNet, you had X25, FDDI, and all these different, and Ethernet was just one of many. And there had to be some pain at that point in the market to select, well, which one is actually going to win out in terms of being scalable, cost effective, and something that people can manage easily. So I think we're experiencing a lot of that too at the application level of we're manufacturing sites that want to, in a scalable way, get all of our data off the plant floor in a way that's going to enable all these different use cases. But the applications to be able to do that are just now starting to be developed. It's not something that's been available for 20 years, and it's just that no one knows of it. These are problems that really need to be solved through new applications and new protocols being developed. So this is just the start of what's going to be a bumpy ride.
Fair.
So
One of the buckle up, no doubt. But one of the concerns that come to mind, even for companies that we're talking with, is that if they are looking at all these different ways to do things, all these different ideas to implement this really new idea. Everybody buys into, or a lot of people buy into the unified namespace, but how to do it and all these different options. And people want to make sure that they select the method that's going to work and be future-proof. Somebody who back in the day didn't select Ethernet probably had to do a lot of rework. And my concern is that whole idea is going to worry a lot of people and stop them from moving forward. And that is a big concern of mine. That we've got to, a lot of people, especially engineers, will analyze situations and have difficulty making a choice to move forward. And so hopefully there's a way to do that. Do you have a real quick thought, and then Dave summarize, and we'll
if it's not difficult enough to, on the technologically networking side, to connect things, just try to get a company to agree on how the UNS should even be structured, that they all agree to a single data model. So the challenge. Thanks
for making it more complicated.
Yeah.
Yeah, all good stuff.
Yeah.
Dave.
Final thoughts for me are that there's a lot that's coming down the pipeline. It's certainly not an easy problem to solve. I'm a big believer in democratizing the data. We talk a lot about having these open systems and open architectures. So what I would focus on is utilizing a lot of the tools that are out there that are open source. And maybe for manufacturing, it means we're going to start using some technologies that exist in other areas of other businesses that we haven't used before, and be open to taking a look at these open architectures, these open source, where I can now use these things to solve problems. So I have a truly democratized technology stack where any application, any problem I'm trying to solve, I can use whatever tool is out there at my disposal. And it makes it that much easier to where when anything plugs into the enterprise, all of that information is made available. I mean, that's ultimately what we're trying to do, is create these ecosystems. So we've talked about several ways of going about it. More will be revealed, and I'm looking forward to it.
Awesome. Great thoughts. All right. Well, that'll be a wrap for the 4.0 solutions conversation around MQTT, Sparkplug-B, and unified namespace on how to get it to work. Guys, this has been a really great conversation. We appreciate Walker and Josh for having us on while Walker is on his sabbatical. Walker, I hope you're enjoying your sabbatical. Please finish that book. Everybody's looking forward to it. And also, Geoff, Matt, Dave, really appreciate you being on. Thank you so much.
Sure.
Thank you.
All right. Take
Enjoy.
care, guys.
Thanks for coordinating us and keeping us on track.
All good. Appreciate it.
Thank you, Kevin. All right. See ya.